GAMS, the alliance formed by Hypothalamus Artificial Intelligence and General Algebraic Modeling Systems. Presence: optimizing aviation operations. Hypothalamus Artificial Intelligence, HAI, and General Algebraic Modeling Systems, GAMS, have agreed on a technology alliance to jointly provide services to the special transport sectors, based on highly complex mathematical models. The technological capabilities of the two companies, in artificial intelligence and mathematical programming, make them ideal partners to face the multiple challenges that exist in advanced analytics applied to the transport sector. Due to the experience of the two companies, this alliance is particularly strong for the optimization of special transport systems such as the aviation industry, planning and operation of ports, and rail systems. GAMS is the strongest alliance in mathematical programming, due to HAI's ability to model complex systems, and GAMS's ability to produce tools for mathematical programming. Optimization value propositions for travel and transportation, TANT, are cost takeout and operational efficiency, optimized workforce and improved customer service, measurable ROI and improved profit, improved market agility and reduced risk, and smarter, greener planet. Optimization-based applications for industries of travel and transportation, TANT uses the following general models: revenue/yield management, asset optimization, fleet assignment, depot and warehouse location, network design, vehicle and container loading, vehicle routing and delivery scheduling, yard, crew, driver and maintenance scheduling. Aviation industry. Mathematical models cover the entire hierarchical chain of decisions, strategy, tactics and operations. Below are real-world use cases, along the decision-making chain, across the multiple subsectors that make up the aviation industry. Multimodal transport industry. The air cargo industry generally includes as part of its operations, the distribution of goods by land, using multimodal transport systems. Federal Express. In 1997, FedEx was the first company in express transport services in the world. With an average revenue of $16 billion per year, FedEx had a presence in 211 countries around the world, 45,000 vehicles, 662 aircraft and 7,800 service centers worldwide. More than 3.3 million packages per day. Frederick Smith, CEO and founder of FedEx, said, "Operations research was effectively applied at FedEx, and reversed the serial design decision of 4 distribution centers in favor of a single super hub. That saved FedEx." Charter fleet optimization. Charter fleet optimization involves mathematically modeling and solving the problem of how to best utilize a charter fleet to maximize profits or minimize costs, considering following constraints: flight demand, aircraft availability, aircraft type restrictions, airport restrictions, crew availability, and minimum flight frequency. Optimized workforce management. Airlines face itinerary disruptions, flight delays, and daily cancellations due to unexpected events, such as inclement weather, mechanical problems with aircraft, and unavailability of flight crews. As a result, crews may find themselves in the situation of not attending their scheduled flights. Airlines must quickly reassign crews to cover available flights, and return them to their original schedules, cost-effectively, while complying with government regulations, contractual obligations, and quality of life requirements for passengers and employees. The main problems in workforce management are staff sizing regulation, rostering, timetabling, task assignment, and monitoring and control. Lufthansa. In 2003, the running time of the monthly crew planning process was manual, and took about 7 weeks. The last step, the crew assignment, took about 2 weeks. Time to market from fleet assignment to actual flight was from 7 to 11 weeks. The challenge was to find the balance between company requirements and individual interests. The goals: the system for crew assignment were The time to market must be shortened significantly, and the crew assignment step must be automated and shortened. The ACA, Automatic Crew Assignment, was introduced as kind of plug-in to the Crew Assignment Editor CAS. ACA transforms the crew assignment problem into a mathematical problem. The benefits of the project were better rosters in shorter times, hours versus days. Duty rosters generated in a more effective, responsive and cost-sensitive way, and very good user acceptance. Optimized fleet management. Vueling airlines. Re-optimization of planning timetables. Vueling needs to adjust the planned flights, this due to multiple reasons of force majeure. Route replanning must respect certain business rules. Cisneria developed Daedalus, a suite of tools aimed to assist airlines and improve their planning processes and operations management. Daedalus comprises 3 different modules: Rotations Builder, Tail Assigner, and Operations Manager. These modules can be used as standalone tools, or work interrelated, to cover a wide variety of planning and operation stages. Vueling is already using Daedalus. United Airlines developed SOA, System Operations Advisor. Between October 1993 and March 1994, SOA saved more than 27,000 minutes of potential waiting. SOA has allowed United to respond to problems in a timely manner that was not possible before. It demonstrates how operations research can be used effectively in the airline operational environment. Revenue management in aviation industry. The Sabre story history, the making of operations research magic at American Airlines. It is the result of the success of operations research in the industrial environment. If necessity is the mother of invention, then deregulation of the airline market is the father, and revenue management, also known as yield management, is the couple's golden child. The relationship between American, Sabre and operations research is as robust and complex as the models and problems they tackle every day, but most of all, it's a richly rewarding relationship for all concerned. AMR, the parent of American Airlines, and step-parent of Sabre Decision Technologies, provided a nourishing home in which soared to unprecedented heights in terms of impact on American, on the entire airline industry, and on a good chunk of the rest of the corporate world. Fueled by constantly improving forecasting and optimization models fed by more and better data, each new generation produced in excess of $100 million in incremental profitability over its predecessor. By 1998, Cook estimates the revenue management system at American Airlines was generating nearly $1 billion in annual incremental revenue. To put that figure into perspective, consider that the airline's total operating profit didn't approach $1 billion until 1997. Today, virtually every airline in the world employs some sort of revenue management system. The concept is also hard at work throughout the cruise, hotel and car rental industries, and wherever else you find perishable, limited capacity. Optimal airplane seat layout. Each airplane has a limited space which can be allocated to first class, business class and economy seats and others. Some factors will influence the decisions regarding the optimal seat layout as follows. The ticket price for each seating category is different, the number of demand for each seating category is subject to uncertainty, and space occupied by each seat type. For example, first-class seats will need more space compared to economy seats. Military aviation industry. Military operations research is embodied in countless solutions to specific real military problems, which support the planning and scheduling of many of the military forces of multiple countries. It can be said that the use of operations research, in military planning, is a very powerful tool, to optimize the use of its force in search of peace. The ADANS, Airlift Deployment Analysis System, is a clear manifestation of the importance of operations research in modern warfare such as the Persian Gulf conflict, which was planned based on 2 operations. I. Desert Shield, before operations, and 2. Desert Storm, war operations. The scale of the logistical effort required to deploy coalition forces in Saudi Arabia, prior to Operation Desert Storm, required the harmonious and coordinated mobilization of air, naval, and land forces from 33 countries, nearly 1 million troops, 200 ships, 2,400 aircraft, 2,000 helicopters and nearly 3,000 tanks. During the first 75 days of Operation Desert Shield, the U.S. Military Airlift Command, MAC, with the help of the Crisis Action Group, mobilized 155,000 tons of equipment and 164,000 troops across the nearly 13,000 kilometers between the United States and Saudi Arabia. To schedule the mobilization, the MAC commander used the Analysis Group, AG, formed in 1986 to provide analytical support to the operations of the MAC, composed of 24 operations research analysts. Add-ins saved in the order of $280,000 per air mission. Phoenix is an optimization model for modernizing the Army's helicopter fleet that is based on a mixed linear programming model. Phoenix optimizes annual costs of operation, maintenance, retirement, extension of service and provision, respecting fleet age restrictions, technology mix, composition, and multi-annual budgets. In 1987 find the optimal mix of new and repowered aircraft for more than 7,000 helicopters. Phoenix considers the minimum and maximum levels of operational aircraft, minimum fraction of highly technical aircraft, average maximum age, maximum and minimum capacities of the production line, maximum and minimum levels of production per year and availability of aircraft as raw material for renewal. Until 1991, the U.S. Army had applied Phoenix to a fleet of 335,000 land vehicles. Warner Robins Air Logistics. The process of repairing and mobilizing the giant C-5 Galaxy military cargo plane is extremely complex and expensive. Routine maintenance of a C-5 takes between 40,000 and 50,000 man-hours. Working time per aircraft averaged 240 days. Despite recent productivity gains at the Warner Robins Air Logistics Center, about 10% of the Air Force's fleet of C-5 aircraft was under maintenance there at any given time. At a time of high demand due to the Iraq War, Warner Robins needed to accelerate the pace and efficiency of maintenance to maintain a high proportion of C-5 in service while facing Air Force budgetary pressures. The C-5 line employs about 24 supervisors and 460 mechanics, organized by skill groups, and enlisted for routine maintenance, or for considerable repairs to the C-5 fleet. In 2005, Warner Robins decided to use operation research to gain efficiency in the complex task of repairing multiple C-5s simultaneously. The implementation of optimization models reduced the number of C-5s under maintenance by 38%, from 13 to 8, in just 5 months. Maintenance time was also reduced by 33%, from 240 to 160 days. The economic benefits of this productivity increase are projected at $75 million. Non-economic benefits include a high speed of response and reduced loss of life in times of war. The main problems in airport planification are capacity planning, ground holding, allocation and scheduling of aircraft in land waiting, and design the exit gate system. Scheduling of activities, allocation of exit gates, baggage claims, and programming landing and takeoff tracks. The main problems in optimized terminal management are strategic planning, size resources, and evaluate design. Tactical planning, check feasibility, and pre-assign resources. Scheduling, final schedule. Control, execute, update, reschedule, and see bottlenecks. Schiphol Airport uses mathematical programming to design of network transportation between terminals. To avoid traffic congestion, a transportation system below ground, with automatically guided vehicles, AGVs, was developed around Schiphol Airport. It is unique in its scale, incorporating 25 km tubes connecting 20 terminals, with 400 AGVs, to carry 3.5 million tons of cargo. To schedule this operation used solutions of mathematical optimization, which includes location of AGVs between terminals, terminal programming, and traffic control. Like Herbert Simon, Hypothalamus AI believes that the computer-based mathematical modeling is the greatest invention of all times. Thank you for your attention.